Existence. Reality exists. This is a parsimonious way of saying reality is known to exist, or even I know reality exists. That there exists a world external to anyone's thoughts on the matter should not be a strikingly profound claim to make, and yet generations of philosophers have allowed the misconception to leak into academia, down into the schooling system, so that now we have people who have been educated into skepticism. Not skepticism of the I don't think ghosts are real kind, but skepticism of the ancient Greek kind. The concern that we cannot know, and because we cannot know, perhaps almost anything goes, including that nothing exists, or that nothing really truly exists, if you like. But let us move beyond the relativists who might claim that there is no external reality, or at least that we cannot make objective claims about it. And let us leave behind the philosophical idealists, those who claim it's all in the mind. Here we might even throw the it's all a simulation idea into the same bin. For there, although there might be an external reality, we cannot know it because we are trapped, like Plato's cavemen, in a world that might bear no resemblance to what we think about it. Let us instead embrace realism, the idea that not only does an external reality exist outside our minds, but that our minds are special kinds of computers indeed, computers that explain the world around us with increasing fidelity. Minds, the minds of people, come to form models, accurate working models, in the words of David Deutsch, of the rest of physical reality. This is an astonishing fact about us. In one of his TED Talks, David speaks about quasars, basically black holes that are literally consuming entire stars and, in the process, creating huge so-called accretion disks, white-hot rotating disks of electrically charged matter spinning so fast that intense magnetic fields are generated that cause jets of material to shoot outwards from the disk, making the quasar brighter than an entire galaxy, despite the fact, in terms of their physical volume, they're smaller than a solar system. The physics, says David, of such an object is so different from that of a human brain, and yet the latter is able to form an accurate explanation, a predictive model, and a physical description of the former. This is astounding, and it is this that allows us to say, quasars exist. But what is existence? What does it mean to exist? A thing exists if it features unavoidably in our best explanations, but not otherwise. We know quasars exist precisely because we have an explanation of otherwise problematic observations. If we did not have those observations, then we would not have a chain of causation which led, both creatively and logically, to that object I just described. No explanation of the physical world out there requires that elves exist, or magical wizards, but explanations of what happens in Tolkien's The Lord of the Rings do. The book, The Lord of the Rings, exists. And that book, being a work of fiction, relies upon the existence of elves and magical wizards for its own internal consistency. Those fictional entities exist within a fictional world, but they do not really exist, which is to say, they do not exist outside of fictional worlds. No explanation of our physical reality requires us to postulate wizards and elves, so wizards and elves do not exist. But now a philosophical quibble might loom. Let us consider gravity. Gravity exists, just like matter exists and space exists. But saying matter exists tells us very little about its nature. Is it continuously divisible, or does it terminate at a smallest possible particle? What is matter? What does it exist as? Atoms, sure, but they are emergent. They are more complex arrangements of more fundamental particles, protons, neutrons and electrons. And even some of those are likewise emergent, more complex objects composed of simpler ones, but never mind matter. What about gravity? Gravity exists. It is that thing which we must invoke in our explanations of, say, tides or the motion of planets, or indeed the frustration of a dropped glass smashing upon the floor rather than hovering in mid-air. But what is gravity? Is it a force? Does the force of gravity exist? It used to be thought there was a force of gravity. The force explanation of gravity was a way of understanding gravity as being the attraction between objects which had mass. On this view, which is the view created by Isaac Newton and which survived for centuries, the force of attraction could be calculated and thus many phenomena accurately predicted. But how the force of gravity arose exactly, no one knew. They merely knew it was a force, so they were right to say at the time, when there was no viable alternative, the force of gravity exists. Now, if we understand them properly, in light of how we understand knowledge today, we should understand that statement to mean we fallibly know that the force of gravity exists. Either that force exists or it does not. There is no middle ground. We have knowledge of it and we are fallible. Our knowledge, everyone's knowledge, at all times we should expect is filled with errors, but it becomes terribly cumbersome to preface everything we say on such topics with, we fallibly know that, and so on. So we can dispense with that because it literally goes without saying. So we just say, the force of gravity exists. But we can always be wrong about that, and we should expect to be. And as it turns out, that is indeed a false claim, because now we know better. There were indeed problems found with Newton's theory. There were errors, and those errors were corrected. An entirely new theory, Einstein's theory of general relativity, was able to make more accurate predictions than Newton's could. And more than this, it postulated the existence of a whole slew of other phenomena and even other objects, ultimately, that existed. And part of this explanation was that the so-called force of gravity was found not to exist. So the force of gravity does not exist. Gravity does. Of course it does. But its true nature does not require us to invoke a force of attraction. Bodies with mass do not attract one another. They may appear to, but then water poured from a kettle into a cup appears for all the world to flow like a continuous fluid, rather than as discrete little particles more resembling dry sand being poured from a bucket. We know those molecules of H2O exist, even though we cannot see them. Our ability to see them moment to moment has no bearing on their existence or otherwise. Their existence is invoked because our best theory tells us they exist, and that water as a continuous fluid, which is to say fluid made of stuff which never terminates at the smallest possible particle, is false. And in the same way, our best current theory decides between two mutually exclusive claims. Gravity is a force versus gravity is not a force. And gravity is not a force. That attraction you think you feel is an illusion, much like the water is a continuous fluid is an illusion. Compelling, sure, but your senses deceive you. If you are able to fall freely, perhaps you've been skydiving, you will feel no attraction to the earth. Sure, if you open your eyes, you will see the ground rushing up to meet you, apparently. But close your eyes. You will feel the wind rush past, sure, but that sensation is no clue about anything attracting you. You will not feel a pull. Instead, you will literally feel weightless. If anything, in this non-ideal situation, you will feel pushed somewhat upwards. Many more of us have had this sensation to a much lesser effect in certain kinds of fun park rides that give you a couple of seconds of free fall before bringing you to a very fast halt. In those moments, I have never noticed attraction to the earth, and I've looked for it. I have felt, in truth, attraction to nothing at all, and if anything, a slight force upwards, and that, of course, is the force of air upon me, resisting my motion. This force, the supposed attraction, a pulling force, just is not there. We know what a pull is. Any friend can pull your arm, and you will notice what it is like to accelerate towards them, but not in free fall. You can be disabused by the illusion of the sensation of the force of gravity by experiment itself. What gravity actually does is distort space and time, or better yet, the single space-time around objects. This means that when objects move, they do not move through a Euclidean space of sharp angles along idealized lines such as in high school geometry textbooks. But does all of this mean that the force of gravity simply winked out of existence the day Einstein published his theory of general relativity? Of course, it never did exist. But were the people prior to this date right to say it existed? Yes, they were right to say it existed, but they were wrong. What else could they do? They could not possibly predict the content of future theories. So we are right today to say the force of gravity does not exist. But does it really not exist? Yes. And if you want to say more, you can say it does not exist according to our best known explanation. But does it really, really not exist? Yes, it really does not exist according to our best explanation. But someone might say, but maybe it really, really, like ultimately in the final analysis, there really is a force of gravity. But there can be no final analysis. It's just constant progress and improvement. Aha, but then you don't really know if the force of gravity exists. No, I really know. To really know something means to really know it. And that means according to our best theory, and fallibly at that. And knowing that the theory is going to contain errors not yet found. When someone wants the really, really true knowledge, they are appealing to a feeling of certainty and finality and infallibility. They are demanding a standard no human can ever reach. Aha, they say, but doesn't this mean we can never really truly know anything? No, you're not quite getting this. We really truly know it. I know it. But you have to give up the notion that know means have the final once and for all completely perfect and error-free answer. Aha, yes, so that's what I meant. Yes, in the final once and for all completely perfect and error-free account of things, does the force of gravity exist? Look, we can't say, aha! So, you don't know after all. Yes, I know. I really truly do. But what you're after is not knowledge, apparently. You don't want to say, I know about gravity. You want to say, you're certain about it. You want to be an omniscient god or an oracle. You want to appeal to the supernatural. Now, there are many such things we could have put into this category. Phlogiston, the substance that made the difference between that which was flammable and that which was not. Perhaps it exists, perhaps it doesn't. So far as we know, it doesn't. Or elan vital, the life force that animated living things. Or the luminiferous ether, the substance permeating all of space which vibrated with the passage of light waves. And add light waves to this list too, by the way. At times we will be mistaken about what exists, but all we can say about what exists is what our best theories say, and nothing more, nothing less. But beyond our knowledge, of course, there are more things than we know to exist. That will always be so, and some of what we think exists will be mistaken. It won't, in truth, exist. But this is no great mystery. It is, as I like to say, the distinction between that somewhat antiquated way of thinking about philosophy, the ontology of the world, which is to say, what ultimately reality consists of, utterly independent of people coming to explain it, and epistemology, what we know about that ultimate reality. We are beings of epistemology, not ontology. Knowledge is, by its nature, conjectural, and so will contain errors. Ontology, on the other hand, is the flawless account of a perfect reality. So knowledge of ontology is something like an imperfect, perfect account, a silly and pointless notion. That reality exists, and we can come to some understanding of it, is quite enough. That our knowledge is by itself imperfect, and always at every moment riddled with errors, is a product of the process that produces it, our minds, our fallible minds. And this is a cause for hope and genuine excitement, for it means that we will have before us a continuous stream of evidence which we can interpret, allowing us to correct the errors in our guesses about what the nature of reality is. We can improve and make things ever better if we choose to. We may err and falter, indeed we will, but this is just to say that we'll never get to a point beyond which progress cannot be made. For if that were possible, then hope would indeed be lost. We'd be at the end. Would have found an answer that could not be improved. Progress would come to a screeching halt. Stasis would follow, and that would be a kind of hell, a perpetual state of nothing changing, and the gradual realization that this is it, where the only novelty would be found in looking back to the past, to a time where it was possible for things to actually get better. But happily, we will not reach the end. There is no end to what we shall discover, and what we will find exists tomorrow. Like everything else we know, what we know to exist is perpetually open to revision, and this allows us, however slowly and incrementally, to gain control of it and to show how its existence can help solve our problems and to make us all the better for having found it.